So, what's the point of doing a virtual co-locating app? I mean, why do we even need to merge people together on the same screen? The answer is not so easy. When you want to collaborate with other people and want to feel more connectedness to them, obviously the best thing to do is to be in person. But why not experiment with how to make people feel more connected? And that's really all that the virtual co-location app is about. Originally, it stemmed from being more performative and supporting performers who were at a distance in the same physical space, so literally 12 feet apart on the same stage. But we figured, well, why can't we do this with people who are 12 kilometers away, or if you prefer non-metric, 12 miles away? So these are our motivating factors for the virtual co-locating app. We don't know exactly how that's going to manifest, how it might improve connections at a distance, how it might change the dynamic and make for more fun, interesting connections. So we're focused now on smaller teams with the application and how it might provide a type of different experience that can be summoned by a team leader when they notice that the team might be bored. Yeah.
Hi guys, welcome to the presentation for Virtual Co-locator. Next slide. So just before I start talking about this project, I just want to introduce our team. We have Dr. Patrick Parapenafather, he is our principal investigator. Myself, the project lead, Olivia, and our software developer, Dante, as well as our designer and artist, Ada. Why did we make Virtual Co-locator? Well, as we've become acquainted to COVID-19 for around 2 years now, during these 2 years, we were forced to work remotely. Distance was physically and emotionally enforced for many, during which virtual meetings were the only safe way to connect with each other casually or professionally. Thus rises this phenomenon of Zoom fatigue or Google Meet fatigue, or whatever fatigue one feels for sitting in front of their computer talking into a void. So we asked ourselves, what can we do about feeling tired or having a hard time being creative in front of a screen? Well, don't worry, Virtual Co-locators got you. This project aims to co-locate participants to grant meaning to and raise engagements to the meeting. So what do we mean by co-locating? Before I get into details about it, let's just say that Virtual Co-locator puts everyone together to make one feel like they're actually talking to each other in a room. And also, our project is actually an extension from the digital Dream Play production that happened last year at UBC. Next slide, please. What's the difference between background photos on Zoom and Virtual Co-locator? To differentiate ourselves from what Zoom already has to target our problem effectively, we did some math. So let's do some math. In Virtual Co-locator assisted meetings, we have Virtual Co-locator plus Zoom screen share equals no more squares. But in regular Zoom, we have black squares plus background photos equals squares with color. So what did we do? Our final product is a standalone app. Although it still has the dependency on Zoom for screen sharing and audio abilities, we've created original artworks for users to choose from. Another really exciting part is that we've used an off-the-shelf software called TensorFlow to implement facial recognition. Next slide, please. Now, before I pass it off to Dante to introduce this new exciting technology of TensorFlow, I'd like to take a moment to showcase the beautiful artwork by Ada Tam, our designer and artist. The media that we used in this app, as I've mentioned before, are all original artworks created from her, which added even more excitement and value to this project. Now, I'll pass it on to Dante to talk about TensorFlow.
So there are essentially two steps that need to be completed in order to get the visualization that we want. First, we need to apply facial recognition to each of the video streams coming in from participants and then get the pixel data for each face. Once we've drawn the face pixels onto a temporary canvas, we can take that image and put it onto the correct or desired position on the final image. Each video stream acts as an image that changes at a certain frame rate. So for each frame, we need to complete the same operation again. Drawing on canvases is a fairly quick procedure, but the bottleneck here is the facial recognition model that we use to calculate the facial pixel positions. One of the core technologies at play here is face recognition with computer vision. TensorFlow provides us with some pre-trained face recognition algorithms, which have a relatively simple JavaScript interface. And that's what we experimented with first. BlazeFace is a really fast model. It achieves a high frame rate and doesn't bottleneck the video. But the problem with this model is that it doesn't provide the developer with precise face outline, and instead the face shape must be approximated from the boxes in the red corners and the blue face features in the GIF that you see in the top left. The math for creating the correct facial outline out of these positions ends up getting pretty ugly. The next model that we tried, and the one that we ended up settling for, is face mesh. Finally, another aspect of a project that required a complex solution was the networking of the different video streams. The diagram here shows the network architecture of our application. Notice how the video data streams are going directly from participant computer to host computer. This means that the server that we've developed doesn't have to actually manage any video streams, and instead just has to aid the handshake between participant and host.
Our future plans. We are intending to continue to develop and refine a robust system for users, as Dante has mentioned briefly. We want to focus on making the app easy and accessible for users. We want to implement the features mentioned earlier. And we're also thinking about possibly expanding the collection of artworks for users to choose from. Finally, in our principal investigators' words, we want to stop fighting with the technology and do what the technology allows us to do. So more possibilities to come with virtual co-locator. And that concludes our presentation. Thank you for coming.